Okay, so in this video, I'll be teaching arithmetic and geometric progression. This topic is part of the A-level math syllabus and it was recently added into the ATMath syllabus as well. So let's begin. Suppose we have a series of numbers 1, 3, 5, 7, 9, 11, and so on. So the first thing you can see is that each term in our series differs from the previous one by 2. For example, our second term is the first term plus 2. It differs by 2. And this is the case for the other terms as well. So if there's a question which asks us to find the seventh term, which is the term after this 11, this sixth term, so you can easily say our seventh term is 11 plus 2, which is 13. But suppose there's a question which asks us to find the 100th term, or let's assume a greater value. Let's say the question asks us to find the 2000th term. So you cannot continue writing this series down. It will take a lot of time. We need a formula for this. And the formula is a plus n minus 1 into d. So what's a? A is the first term, which in this case is 1. 1 is our first term because our series begins with 1. A is 1. What is d? D is the common difference. The common difference in this case is 2 because each term in the series differs by 2. So common difference d is equal to 2. So if we use the values of a and d and put them in the formula, we'll get 1 plus n minus 1 multiplied by 2 and 1 plus 2n minus 2. So 2n minus 1. Okay. So now let's check if our formula works. So our seventh term was 13. Now let's replace n with 7. 2 into 7 is 14 minus 1 and we get the answer 13. So you can see that this formula works. Now you can use this formula to find any value, any term. For example, if the question asks you to find the 100th term, so you can easily say that we have the formula 2n minus 1, and if we put 100 as the value of n, so we get 2 into 100, 200 minus 1, and we get 199 as the answer, and it's the value of the 100th term. So now let's move to another example. Suppose we have another series 9, just wait a minute, 9, 6, 3, 0, minus 3. Now for this sequence, you can see that each term differs by minus 3. The second term is the first term minus 3, and the third term is the second term minus 3. 9 minus 3 is equal to 6, 6 minus 3 is equal to 3, 3 minus 3 is equal to 0, and 0 minus 3 is equal to minus 3. So our common difference is minus 3. What about our first term? Our first term is 9 because our series begins with 9. So a is equal to 9. Now let's use this in the formula. A plus n minus 1 multiplied by d. A is 9 plus n minus 1 multiplied by d. So the sign is important. As you can see in the previous example, we used, since the common difference was plus 2, we used plus 2. But now, since the common difference is negative, we'll have to write minus 3. Otherwise, this formula won't work. Okay, so let's simplify it. Minus 3 into n is minus 3n, and minus 3 into minus 1 is plus 3. 9 plus 3 is 12 minus 3n. Now let's check if this formula works. So our first term is 9. So 12 minus 3, 1. We'll use, since it's the first term, we'll use 1 as the value of n. 12 minus 3 is 9. So this means this formula is working. Now let's check it for the fourth term, which is 0. Fourth term, so 12 minus 3, and we'll use 4 as the value of n, since we have to find the value of the fourth term. So 12 minus 3 into 4 is 12, 0. And you can use this formula to find any term. For example, if we continue this series, we'll get minus 6 for the sixth term and minus 9 for the seventh term. You can check this by using this formula as well. 12 minus 3 into 6, which is 12 minus 18. 12 minus 18 is minus 6, and 12 minus 3n, and n is 7 because this is the seventh term. So you'll get 12 minus 21, which is minus 9. So you can see this formula works.